In this video, I'm going to show you how to make graphs and handle graphic objects. First, by now you probably know you can create a graph from the Settings and Variables window. Click the variable and press the Enter key. Another way to make a graph is using the function plot. This is similar to the plot function in MATLAB, at least in the beginning. So plot parentheses x, the classic style, or x.plot, the object-oriented programming style. Either way, the same. You are making a plot and return the graphic handle, in this case a line object. But there is an important difference between the two ways of graphing. The graph generated from the Settings and Variables window is attached to the variable. Therefore, as the variable changes, the graph is updated accordingly. I'm changing x to a random sequence. See the graph change automatically. I'm calling this named plot. The title bar of this figure window shows the name of the variable. On the other hand, the graph generated with the plot function is what I call an unnamed plot, so once the plot is made, it is independent of the variable. The title bar says figure and a number. This is the behavior of the plot function in MATLAB. As a MATLAB user, you may be too familiar with the situation where you have to manually plot the graph every time the variable changes. This unique feature of named plot in AUXLAB will make your life easy. However, in most other videos, I've been using named plot for the purpose of giving demos, so in this video I'm focusing on unnamed plot to show you graphic programming features in AUXLAB. Now, graphic handles. If you're familiar with graphics in MATLAB, you may find this easy to follow. Working with graphic handles in AUXLAB is similar to MATLAB. Just watch for some differences or unique features in AUXLAB. If you don't know MATLAB graphics, here it is. A graphic handle is a class variable, which means it has a bunch of properties attached to it. They show us the detailed information about the graphic object, and we can change it as we want. First, there are 5 types of graphic handles, and they are related in hierarchy. A figure object can have axes or text objects in it. An axis object has 2 axis objects for x and y, and multiple line objects, and so on. They are linked in parent-children relationships. These are properties for each object type. Some properties appear across several object types. For example, the color property is found in all types. Other properties are used only for certain object types. For example, the box property is for the axis object, the limb property is for the axis object. Now, there are other graphic functions you might need to use in addition to the plot function. First, close the existing graphs. Call the plot function again and get the line handle. First, I'm going to make the line thicker. Increase the width of the line. So the new value of lx.width is 5. Then I want to change the line style to dotted line. So lx.line_style is going to be colon, which is dotted line. Okay, now let's use a marker for each data point. This is a triangle marker. Changing the color of the line. The color parameter is specified with a 3-value vector RGB, red, green, blue from 0 to 1. I'm just putting a random color vector. There you go, a greenish color. Now, let's change the color of the axis. So get AX, the parent of this line. Let's just look at the axis color vector. I'm just adding a little bit to the first, the red component. There you go. Now, how about changing the position of this figure? Get the figure handle, the parent of the axis. POS is the position property. The first 2 values are the screen coordinates from the top left as the reference. The third and fourth values are width and height in pixels. Change the first value of the position, then second value. There we have new position of the figure. Now, a different example. I want to make a new graph. If I just call the plot function, it'll override the existing figure. So I'm making a blank figure, then call plot for sequence of sign. So the axis of this new graph is AXFIG2. Now I'm going to change the position of this axis object. You may look at Settings and Variables window, double-click AXFIG2. Then you see the properties. Look at the position property. Here, I'm following the convention in MATLAB for the position of axis. The first is a horizontal gap from the left of the figure window. The second is the vertical gap from the bottom of the figure. The third and fourth are the width and height. All are in proportion relative to the figure window. So if we reduce the fourth value by half, it'll shrink the height of the axis area. Indeed, it did. Now let's add another axis to this figure, called the axis function. The first argument is the figure object, the parent or where you want to create the axis in. The second argument is the position of the new axis. Here, I want to make the new one appear just above the existing one, so I'm just using the position of the existing axis plus 0.43 to second value. Let's make an XY plot in the new axis. Define a pair of vectors as an example, like these. A.plot, parentheses, B, and O dash, specifying the plot option. Also, I'm adjusting the range of X and Y axes. The function line is similar to the function plot. The only difference is that it adds the line object to the axis regardless of the axis property next plot, so don't have to worry about overriding. I'm adding a mirror image line here. Now I'm going to add a text message on the figure window. The function text adds a text string on the current figure. The first and second argument are the position of the text to put in a relative proportion to the figure window. Now change the font size and change the font name.